The more tools you have, the more easily you will understand geometry. The perpendicular bisector theorem is a great tool to have in your geometer's toolbox. All good learning begins with vocabulary, so we will focus on the two important words of the theorem. Perpendicular means two line segments, rays, lines, or any combination of those that meet at right angles. A line is perpendicular if it intersects another line and creates right angles. A bisector is an object, a line, a ray, or line segment that cuts another object, an angle or line segment, into two equal parts. A bisector cannot bisect a line because, by definition, a line is infinite. Putting the two meanings together, we get the concept of a perpendicular bisector, a line, ray, or line segment that bisects an angle or line segment at a right angle. So when we put everything together, what does the perpendicular bisector theorem say? It says, if a point is on the perpendicular bisector of a line segment, then it is equidistant from the endpoints of the line segment. Let's talk about proving the perpendicular bisector theorem. With only a line segment, HM, and its perpendicular bisector WA, we can prove this theorem. We are given line segment HM, and we have bisected it, divided it exactly in two, with line segment WA, which bisected HM at 90 degrees because it is given. This means if we run a line segment from point W to point H, we can create right triangle WHA, and another line segment WM creates right triangle WAM. Now, we have two right triangles sharing side WA with all these congruencies. WA is congruent to WA because it is the same line segment used in both triangles. Angle WAH is congruent to angle WAM. These are given 90-degree angles. HA is congruent to AM because WA is a given as a bisector. This information allows us to apply the side angle side postulate, which states, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then these two triangles are congruent. Since we know these two triangles are congruent thanks to SAS, we also know that sides WH and WM are congruent because of CPCTC. Corresponding parts of congruent triangles are congruent. Now let's talk about the converse of the perpendicular bisector theorem. You may have noticed that this theorem is constructed as an if-then statement. This immediately suggests you can write the converse of it by switching the parts. If a point is equidistant from the endpoints of a line segment, then it is on the perpendicular bisector of the line segment. You can show this too. Let's construct a line segment HD. Place a random point above it, but still somewhere between points H and D, and call it point T. If point T is the same distance from points H and D, this converse statement says it must lie on the perpendicular bisector of HD. You can prove or disprove this by dropping a perpendicular line from point T through line segment HD, where your perpendicular line crosses HD, call it point U. If point T is the same distance from points H and D, then HU is congruent to UD. If point T is not the same distance from points H and D, then HU is not congruent to UD. This symbol means not congruent to. That's it. You are now able to recall the perpendicular bisector theorem and test the converse of the theorem. You also got a refresher on right triangles and what perpendicular, bisector, and converse mean.